Class, today we'll look at a simple example that use ANSYS Workbench to solve a steady state thermal analysis problem. Okay, the problem we will solve here is a 2D problem. The structure is annulus region where when in the inner boundary, A equals 1 meter, temperature is 100, and the outer region, in the outer boundary, where B, the diameter B equals 2 meters, there's a heat flux going to it. The heat flux is 200 watt per unit area, meter squared. Okay, so you can imagine that the temperature outside should be higher than temperature inside because the heat flux going into it. The material we'll use is structured steel, and so the thermal conductivity is given. The problem is to determine the temperature field and the heat flux within the region. We know that this is a simple 2D problem. We can solve it by solving the steady status thermal conductivity equation, and the analytical solution is provided here. The analytical solution temperature will change with radius r. R is the radius, and then you have two coefficients. The first coefficient is 400 divided by k, which is 60.5, and well, the other constant is 100. So, and r equals 2 meters with the outer boundary, so temperature should be 104.58, which will be used to validate our simulation result. So let's move on to our workbench study. So here we'll create a new project, and the project this time we'll use is steady state thermal analysis. So choose steady state thermal analysis. Well, for the engineer data, for the material we use is structural steel, so you can have a quick check is the material property, which is 60.5, which is exactly what we want, so means the data is good. And then we go to geometry, where before we draw the geometry, make sure that this is a 2D type, so we'll work on 2D and surface bodies. Then after that, launch geometry editor, space claim. Now, first thing we want to set the unit. So the radius is 1 meter and 2 meter. So we'll change the unit to meter. And minor grid spacing, let's set as 1 meter. Click OK. And right click, select new sketch plane. Click plane view. Here we'll draw two circles. First start from center. And the first circle, the radius is 1, that means diameter is 2. So that's the inner circle. The second one, start from center, is with diameter 4. Right. So with two boundaries properly drawn, we will click pull, and we click pull, and we'll generate a surface instead. So we draw two circles, now we have a surface. And the next step is click select, or pick the middle circle area, and we delete it. Click delete on your keyboard. Now we have this area, and we close it. We quit from space claim, and then we click on model, double click model, which will launch the mechanical modeler. Now we are in mechanical modeler where it will load geometry we have created. Take some time, let's wait. Now we in it, so the first thing is always check whether the material has been assigned. So the material is structural steel, which is right. And then we go to mesh. Here we'll insert a sizing, click sizing, which will choose this surface area and then apply. So the surface area has been chosen. And for the element size, let's see, we put 0.05 there. And then we generate a mesh. Oh, the mesh is too fine. So let's change it to a little bit larger. Let's change to 0.1. We don't need that so much refined mesh because it's 2D. You really don't need that much refined mesh. And generate mesh again. No, this time is good. It's very fine mesh, but it's not that we don't need much calculation because it's not as over refined. Okay, now the next step is to set up the boundary condition. So the first boundary condition we'll set up is temperature. So we'll apply inner edge to it and then apply. So we apply inner edge at the temperature to 100, and then we insert another boundary condition, which is heat flux. The heat flux is 200 watt per square meter. And then we'll also need, don't forget, assign to the other edge. So assign. And the insert solution, thermal, temperature, and I also want to look at is heat flux. And then after that, solve. After solving, we'll see the result. This is a 2D problem. It will not take a very long time. All right, and then we look at the temperature. And you'll see the temperature from inner side 100 degree Celsius degree, and outer boundary is 104.58, which is exactly the analytical solution. Okay, and then total heat flux start from inner side is 400, outside is 200. So well, why inner side has a larger heat flux because the total area becomes smaller. Area times the heat flux will lead to the power or energy per unit time. Okay, so well, you can show, because heat flux is a vector, so you can also show vector format, and zoom in, you will see that how the heat flux go into it and gradually increase. All right, and with this, and that's what we have for today. And wish you enjoy the video, and we'll see you next time.